Circuit tracing systems are essential tools for identifying branch circuit breakers, especially in older buildings with potentially inaccurate or missing panel schedules. There are several options available. Firstly, the AmProbe ProScan 3000 is a versatile circuit tracer suitable for both energized and de-energized circuits. It features a color-coded display to clearly identify circuits and includes both a tone generator and a probe. Secondly, the Ideal SureTrace 1000 is similar to the AmProbe ProScan, offering non-contact detection of live circuits. This tracer provides both visual and audible indicators. Thirdly, the Klein Tools ET200 Circuit Breaker Finder is a handheld unit that uses magnetic induction to locate circuit breakers. It operates on live circuits and features a backlit liquid crystal display or liquid crystal display. While WIGs and other voltage detectors may seem useful in some situations, they come with significant limitations. One such limitation is the potential for false positives, where these devices may indicate voltage presence due to stray voltage or induced currents, even when a circuit is not actually energized. Readings from these devices can be erratic, varying based on the distance from the wire and the angle of the probe, making it difficult to obtain consistent and reliable measurements. It is discouraged to rely on these devices for life safety applications, as they may not always provide an accurate indication of circuit status, thus creating a potentially hazardous situation. To ensure safety and accuracy, it is best to utilize circuit tracers to accurately identify branch circuit breakers, thereby minimizing power interruptions during the remodel. Examine the electrical panel and carefully note the labels or numbers corresponding to each branch circuit. Use a multimeter to confirm the identity of circuits by measuring voltage continuity or resistance. Once circuits are positively identified, label the breakers appropriately for future reference, ensuring accurate and up-to-date panel schedules. Communicate effectively with tenants, informing them of any planned power interruptions and providing reasonable notice. Work in stages, disconnecting and reconnecting circuits incrementally to minimize the impact on tenants and to allow for efficient troubleshooting should any issues arise. When selecting a circuit tracing system, prioritize those that offer both visual and audible indicators for clear circuit identification. A color-coded display can be particularly helpful in differentiating between circuits, reducing the chance of errors. Look for traces that can be used on both energized and de-energized circuits for maximum versatility in different situations. Always confirm the accuracy of any circuit identification using a multimeter to measure voltage continuity or resistance. Before commencing any electrical work, de-energize the circuit and verify the absence of voltage using a reliable voltage tester. Only rely on voltage detectors as a secondary verification tool, not as a primary means of determining circuit status. When using a multimeter, select the appropriate voltage range and test known energized and de-energized circuits to ensure the meter is functioning correctly. Wear appropriate personal protective equipment, or PPE, including safety glasses and insulated gloves, to minimize the risk of electrical shock or injury. Before making any connections or disconnections, double-check the circuit identification to avoid accidental interruptions to other tenants' power supply. Keep accurate records of all circuit changes, including updated panel schedules and wiring diagrams to facilitate future maintenance and troubleshooting. Adhere to all applicable electrical codes and regulations to ensure the safety and compliance of the installation. Conduct thorough testing of all newly installed circuits to verify proper operation and compliance with safety standards. Provide tenants with clear instructions on how to report any electrical issues or concerns during and after the remodel. Regularly inspect the electrical panel and branch circuits for any signs of damage or deterioration and address any issues promptly. Grounding is a critical aspect of electrical safety. Ensure all circuits are properly grounded to provide a path for fault current and minimize the risk of electrical shock. Verify the grounding system's integrity using a ground impedance tester. The neutral conductor carries the return current from the load back to the source. Ensure the neutral conductor is properly sized and connected to prevent voltage drops and overheating. Avoid overloading circuits by ensuring that the total load on each circuit does not exceed the rated capacity of the breaker or wiring. Use appropriate wire connectors and ensure they are properly tightened to prevent loose connections, which can cause overheating and electrical arcing. When working with aluminum wiring, use connectors and antioxidant compounds specifically designed for aluminum to prevent corrosion and ensure a reliable connection. Protect wiring from physical damage by routing it through conduit or other protective enclosures. Use strain relief clamps to prevent tension on wire connections, which can lead to loosening and failure. Label all electrical boxes and panels clearly to indicate the circuits they serve and any safety precautions. Educate tenants on basic electrical safety practices, such as avoiding overloading circuits and using appliances safely. If any doubt about electrical work exists, consult a qualified electrician for assistance. Remember that electricity can be dangerous, and it is essential to prioritize safety at all times. When dealing with older wiring systems, be aware that insulation may be brittle or deteriorated. Handle wiring carefully to avoid damaging the insulation and replace any damaged wiring. Use appropriately sized breakers to protect circuits from overcurrent. Ensure that breakers are properly seated in a panel and that they trip correctly when tested. When installing new outlets, use tamper-resistant outlets to protect children from electrical shock. Follow manufacturer's instructions for all electrical equipment and components. Periodically inspect electrical cords and plugs for damage, and replace them if necessary. Avoid running extension cords under rugs or furniture, where they can overheat and become a fire hazard. Unplug appliances when not in use to save energy and reduce the risk of electrical shock. If you experience frequent tripping of breakers or blown fuses, investigate the cause and correct the problem. Never attempt to bypass or disable safety devices such as breakers or ground fault circuit interrupters, or GFCIs. Install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms and kitchens, to protect against electrical shock. Test ground fault circuit interrupters, or GFCIs, monthly to ensure they are functioning correctly. Keep electrical panels and equipment clean and free from dust and debris. Use a non-contact voltage tester to check for voltage before working on any electrical circuit. If you suspect a problem with your electrical system, contact a qualified electrician for a professional inspection. Never attempt to repair electrical equipment unless you are qualified to do so. Consider installing surge protectors to protect sensitive electronic equipment from voltage spikes. Keep flammable materials away from electrical equipment and wiring. Have a fire extinguisher readily available in case of an electrical fire. Know the location of the main electrical disconnect switch in your building. In case of an electrical emergency, turn off the power at the main disconnect switch. Call emergency services immediately if anyone is experiencing electrical shock or if there is a fire. Be aware of the signs of electrical overload, such as flickering lights, warm outlets, or a burning smell. If you notice any of these signs, reduce the load on the circuit or contact a qualified electrician. When working with electricity, always take your time and be careful. Rushing can lead to mistakes and accidents. Remember that electrical work can be dangerous, and it is important to prioritize safety at all times. The NEC, or National Electrical Code, Article 210.12 requires arc fault circuit interrupter, or size protection for branch circuits that supply dwelling unit receptacles, lighting, and other loads. Arc fault circuit interrupters, or size, are designed to protect against electrical fires caused by arcing faults. The NEC, or National Electrical Code, Article 310.15 specifies the allowable ampacity of conductors based on their size, insulation type, and installation conditions. The NEC, or National Electrical Code, Table 310.16 provides ampacity ratings for various conductor sizes and insulation types. The NEC, or National Electrical Code, Article 250 covers grounding and bonding requirements for electrical systems. The NEC, or National Electrical Code, Article 406.4 requires that receptacles installed in damp or wet locations be protected by ground fault circuit interrupters, or GFCIs. The NEC, or National Electrical Code, Article 408 covers requirements for electrical panel boards and enclosures. The NEC, or National Electrical Code, Article 547 covers requirements for agricultural buildings. The NEC, or National Electrical Code, Article 680 covers requirements for swimming pools, spas, and hot tubs. The NEC, or National Electrical Code, Article 700 covers requirements for emergency systems. The NEC, or National Electrical Code, Article 701 covers requirements for legally required standby systems. The NEC, or National Electrical Code, Article 702 covers requirements for optional standby systems. The NEC, or National Electrical Code, Article 705 covers requirements for interconnected electric power production sources. The NEC, or National Electrical Code, Article 725 covers requirements for Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. The NEC, or National Electrical Code, Article 760 covers requirements for fire alarm systems. The NEC, or National Electrical Code, Article 800 covers requirements for communications circuits. The NEC, or National Electrical Code, Article 810 covers requirements for radio and television equipment. The NEC, or National Electrical Code, Article 820 covers requirements for community antenna television, or CATV, and radio distribution systems. The NEC, or National Electrical Code, Article 830 covers requirements for network power broadband communications systems. Always consult the latest edition of the NEC, or National Electrical Code, for the most up-to-date requirements. When replacing old electrical equipment, be sure to use equipment that meets current safety standards. Do not mix different types of metals when making electrical connections, as this can lead to corrosion. Use electrical tape that is specifically designed for electrical applications. When making wire splices, use a crimping tool that is designed for the size and type of wire being spliced. Avoid using wire nuts on solid wire, as they can loosen over time. When installing recessed lighting fixtures, ensure that they are rated for the type of insulation being used in the ceiling. When installing electrical boxes in walls, ensure that they are securely attached to the framing. Use cable staples that are designed to prevent damage to the cable insulation. When running cable through metal studs, use grommets to protect the cable from sharp edges. When installing conduit, ensure that it is properly supported and secured. Use a conduit bender that is designed for the size and type of conduit being bent. When pulling wire through conduit, use a lubricant to reduce friction. When connecting equipment to ground fault circuit interrupter, or GFCI circuit, ensure that the equipment is properly grounded. When connecting equipment to a surge protector, ensure that the surge protector is properly grounded. When working on energized circuits, use insulated tools and wear insulated gloves and eye protection. Never work alone when working on energized circuits. Have someone nearby who can assist you in case of an emergency. If you are not comfortable working on electrical circuits, hire a qualified electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. Remember that safety is always the top priority when working with electricity. By following these best practices, you can minimize the risk of electrical shock, fire, and other hazards. With careful planning, proper tools, and a commitment to safety, you can successfully complete your electrical remodel while minimizing power interruptions and ensuring the safety of your tenants.